Our group is Urbanholic. Our project's goal is to see how cities build up areas changing in the past 2 decades. We picked two cities to study, London and Shanghai. London has been a major city since the beginning of the 20th century. It has been fully developed by the middle of the century. Shanghai, however, started to develop in 1990s. Our research question is whether the build-up areas of these two cities have changed in the past 2 decades. The goal of this project is to see how these two cities change in built-up areas between 1995 and 2050 using remote sensing methods. To achieve this aim, we downloaded Landsat data from USGS Earth Explorer. For each city, we downloaded 5 images with a time span of 20 years. To ensure image quality and terrain consistency, we decided that for the same city, the image dates should be in the same season so that the plant's phenological cycle would not affect the results. In order to provide a visual result to show the change of the built-up area in each city, maximum likelihood classifier is used to calculate numerical results of urban area based on pixel classified as urban in images.
Now let's go through the data and the classification steps. As we mentioned before, we want to make sure that images from the same city would be not affected by the plant phenological cycles. We decided that for London, data in summer are used, and for Shanghai, we use data in winter. We started by defining pixels in these three categories: urban built-up areas, water, and greenland. Next, we manually chose extents in each satellite image that fit into each categories and labeled these extents. The maximum likelihood algorithm was then able to read through the characteristics of each Landsat bands of these labels. 20% of the pixels were then randomly selected from the image. The algorithm would use the characteristics to classify these unlabeled pixels. The results of the classification was then plotted on the image to determine number of pixels that were classified as urban built-up areas. It should be noticed that some images have clouds, and when we define the labels, we try to define pixels with clouds with the nearest feature from one of the three categories. Now let's see the results of the two cities. Based on the classification results of London satellite image, we found that from 1995 to 2015, there is a slight decrease of urban built-up area. What we show here is the satellite image and classification results of London in the year of 1995 and 2014, the beginning and the end of the time series analysis. In 1995, the built-up area takes up 65.8% of the total area. In 2014, the percentage is 54.2. A line graph showing the percentage of urban built-up area in the time series is shown here. It can be seen that over the time span of 19 years, built-up area have been decreasing at a rate of 1.72% per year.
Now let's see what's happening in Shanghai from 1995 to 2016. Visually, we can tell dramatically increasing urban built-up area from comparison between classification result in 1995 and the result in 2016. Statistically, the built-up area has expanded from 11.1% of total municipal area, excluding the area of water, in 1995, to 44.3% of total area in the beginning of the 2016, shown in the figure 6. In result, urban area of Shanghai is expanding at the rate of 8.78% per year. To conclude this, as a developed city, London does not have an obvious urban built-up area change in the past 2 decades. As we mentioned before, there is a slight decrease. Shanghai, on the other hand, shows a apparent increase from 1995 to 2016, with a triple of the built-up area over the period. Overall, the maximum likelihood classification is a significant tool to study land cover types. For further researches, higher resolution and cloud-free data, if available, will be useful for checking the quality of classification results. Thank you everybody for listening our presentation and have a great day.